R provides us with the hist function to create histograms. In this video, I'll demonstrate the hist function with a few examples to highlight its parameters. For this demo, I'm going to use the built-in dataset for air quality. I can bring up the description of this by typing !air quality or help air quality. And this tells me it's the New York air quality measurements from May to September 1973. So it gives me 6 variables or 6 columns. And for this, I'm going to plot first the temperature. So we can do a histogram, the most basic histogram. We do hist. Give it one of the air quality columns. Let's plot the temperature data in a histogram. And we get a very basic uncolored histogram. We could do the same thing with the wind. And there's the wind data plotted as a histogram. Now there's a number of parameters to make greater sense of our data. I'm going to create an R script and give you a more comprehensive hist function. So I'm going to first get some colors into our histogram. So we can create a vector of colors, say red, yellow, let's put a few more in, blue, green. And if it has more bins, then it will reuse these colors. So that's fine, 4 different colors. Now let's try hist function again on our air quality. Let's say for our wind, instead of frequency, let's plot the density. So we'll set frequency false. We want left closed intervals, so we can set right. So if right is true, it's right closed intervals, right false. And same with frequency. We can switch from frequency to density by setting the FREQ parameter. I can specify my colors. And let's put a label on it. So our main label, our title here, we can change by the main parameter, and we give it a string. Let's call this New York wind speed. And we'll change our X label. So this label across the bottom from air $wind to wind speed. So if I run this script now, we'll get a slightly nicer histogram, or a nice brightly colored one. Now, on top of this, sometimes we want to plot this as a density plot. So I'm going to give it a line plot that's going to overlay on top of my histogram, giving the same data, except in this case, a density line plot. So I'll tell you what these parameters are in a second. So we're plotting the density. We want the bandwidth to be 1, the color to be red, and the line width, we'll make it nice and thick, 3 times the normal or the default. So let me run this, and you should see a line appear on top. So we get this line. Red was a bad choice. Let's do black. So it's running again. Oh, save here. Let's run that again. There we go. Get our density plot. So what the bandwidth does, if I put a larger number, the line will smooth out, be fewer bumps. Let's do something 0.7. It should make it a little bit bumpier. So it kind of follows our histogram. Now, if we want more bins in our histogram, you'll see some of these plots go. There's some white space here. I think the density line gives us a more accurate representation of our data, but I can increase the bins by using the breaks. And so what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's try 15 or 16, comma, and run this again. So here we get a few more data points. Gives us a better sense of what's going on here. I can even drop this down, change our density plot, It's a few more bumps. So you can play around, whatever fits best. You can even decrease the number of bins by changing the number of breaks. So this breaks parameter for histogram. So here 6, that's terrible representation. 20 is probably too many. That's not too bad. So if I let's bring up hist in the help. There's quite a few parameters. They're all labeled here. I encourage you to play around with it and get a sense of some of them that you may want to use for your own purposes. And that'll conclude this video on the rhist function.